So we are doing a review for exam 2, which will be chapter 3 and 4, and we're going to do some homework questions. So 4.50. Okay. 4.50 says grams of iron 3 sulfide. So they're looking for, let me give myself a little bit of space here and bring the book over. All right. They're looking for grams of iron 3 sulfide when 0.620 mils of 0.135 iron 3 chloride are mixed with a certain concentration in milliliter of calcium sulfide. First thing you got to do is write a balanced equation. So we've got FeCl3, iron 3 chloride, which if we look up should be aqueous. Aqueous plus calcium sulfide, which calcium is a +2, sulfur is a -2, so they're a 1-to-1 relationship. We're going to switch partners, and we're going to make calcium chloride, CaCl2, which should be aqueous, plus our solid iron sulfide, which should be Fe2S3. Now, if you can't balance the equation out, you're not going to be able to do this problem. What's going on, Trent? Okay. So we need to be able to balance it. 1 iron, 2 irons. Let's put a 2 out here and see how this works out. 2 irons, 2 irons. 6 chlorines. I got 2 over here. Let's put a 3. Okay. That gives me 6 chlorines, 6 chlorines. Now I have 3 calciums. So I need a 3 here, 3 calciums, 3 calciums, 3 sulfurs, 3 sulfurs. So let's double check it. 2 times 1, 2 irons, 2 irons. 6 chlorines, 3 times 2, 6 chlorines. Okay, so 2 times 3 there. 3 times 1 on the calcium, 3 times 1 on the calcium, good. 3 times 1 on sulfur, and a 3 there on sulfur. We have a balanced equation. Now, the info that they give you is they say that we've got 62 mils of 0.135 molar iron 3 chloride. 62. All right, 62.0 mils of 0.135 molar, and that's the FeCl3. We're adding it to 45 mils of 0.285 molar. Okay? And they want to know, the question they want to know is how many grams of iron 3 sulfide will we get out? So they want to know the grams of iron 3 sulfide. Okay, they want to know these grams. Okay. Now, I got to get my calculator here, aka phone. All right, let me open it up. All right, hold on, it just crashed on me here. Time for a new phone. All right, so here we go. The first thing we have to do is figure out how much of each of the reactants we're adding. So, remember, molarity equals moles per liter. We're going to take advantage of that. Okay. So, I've got 0.135 molar, and I've got 62 mils of it, which is 0.062. I've got 0.25 molar, 285, sorry. And we have 45 mils of that. All right, that's step one. Well, step one is really balance the equation. If we want to go through steps again, this is step one. This is step two. Figure out the number of moles of each reactant that you have. Okay, so we're solving for X here. I got to do some cross multiplying. 0.135 times 0.062. Okay, this is X here equals 0.0084. And that is moles of iron 3 chloride, FeCl3. Now we're going to do the same thing for this one. 0.045 times 0.285. 0.013. 0.013. This is 0.013 moles of CAS. Okay? You guys with me so far? Now I need to figure out my limiting reagent. I got to figure out which one's going to give me the least amount of product. And the product I'm looking for is this one right here. So I've got to convert each mole's reactant. This is no different than what we did in chapter 3 when we were given grams of two products, converted it to moles, and then figured out my mole ratio. The only difference is instead of being given grams, you're given molarity and volume. Okay, so this is liters here, this is liters there. That's the only thing that's different. So we have our moles. So our next step is to convert those moles to moles of product and see which gives me the least. Okay, so I'm going to do my mole ratio here and here. Okay. So my mole ratio of iron 3 chloride to iron 3 sulfide is 2:1. My ratio of CAS to Fe2S3 is 3:2. So we do the math. 0.08. I just want to double check my math here. 0.135. That one's right. 0.045 times 0.285. That one's right. Okay. All right. So 0.013 divided by 3 is 0.004. So this one okay, is 0.004. Cross that out. Cross that out. Moles of Fe. Fe2S3. And this one up top is going to be they're both going to be 0.004. How about that? This one's also going to be 0.004 and change. This one's like 4.2. This one's 4.2 and change. So, this is step 3. Figure out your moles of your product to figure out your limiting reagent. Okay. So it looks like both are going to give us the same amount of product, which means they're both my limiting reagent. I don't have a limiting reagent. So they're both my limiting reagent. The ratio comes from the balanced equation, Trenton. So this is 2 to 1 because 2 to 1. And this one's 3 to 1 for 3 to 1. So your first step is always write out a balanced equation. Okay, so they're both my limiting reagent. Now, if this one was my limiting reagent, we would use their value to find our grams. If this one was the limiting reagent, we'd use this one to find our grams. But since they're both the same, we could find our grams. Now, just for board space here. Okay. Kelsey, did you find iron 3 sulfide's mass by any chance? I'll actually just look it up here. Iron 3 sulfide mass. Here we go. 207, 208, 208. Okay, so our last step, I'm going to erase this here. We have that 0.04 that we found. 0.004 that we found. Our last step, step 4 then, is to take our limiting reagent product prediction, the 0.004 of iron sulfide, and use the molar mass of iron sulfide. So 2 irons plus 3 sulfurs, and I just looked it up, it's 208, 208 grams of Fe2S3, 1 mole of Fe2S3. So I'm going to take that 0.004, I'm going to multiply it by 208, and I'm going to get 0.901 grams of Fe2S3. Now, as long as all my math is right, that should be our answer. Okay. Questions? Yep, so if you did the same thing, but your rounding was a little bit different, so that one of them ended up being a little bit off. I basically rounded where I rounded, but yeah, you're in the right place. If you had an answer like, let's say, 5 grams, or an answer like 0.001, then I'd be a little concerned. So yeah, just our rounding is a little different, and that's okay. Because, if you round to 0.00837 and take it out to that many decimal places, which you should because of the limiting, are of the sig figs for board space and, conforming here. But as long as you're in there and you're close to that, you are doing it correct. All right, what were the other ones? Let me scroll back up here what you had. 4.69. Same identical problem on 4.69, but we'll do it. But it's the same identical principle. Okay, any questions on this one before I get rid of it and do the next one? All right, so let's go on to that 4.69. How many milliliters of 3.83 molar HCl are needed to react with 16.2 grams of calcium carbonate? Okay. Let me just see what formula they're giving us here. All right. What number did I say this is? I'm talking to myself here. 4.69. You know what? Let me do 4.70, Kelsey. Is your question on how to do it, or specifically that one? Because the reason I'll do 4.70 is the 4.70's answer isn't in the back of the book. 6.9 is in the back of the book. 4.69 is in the back of the book. 4.70 is not. But it's the same type problem. No, actually it is milliliters. We'll just do 4.69. Whatever. Potato. It's all good. All right. So 2HCl plus solid calcium carbonate. Okay. 2HCl aqueous plus CaCO3 solid yields calcium chloride, CO2, and water. Okay. All right. Now the question says how many milliliters of HCl, so they want to know milliliters of HCl, are needed to react with 16.2 grams of calcium chloride, or calcium carbonate. So they give us 16.2 grams of calcium carbonate. Now the question is, they're asking for mils of HCl. Okay, they're asking for mils of HCl. Well, the thing that they gave me is they did also give me a molarity of HCl. They said that HCl's molarity is 0.383. So they told me I had 0.383 molar HCl. Okay? Now, since they did that, and they want to know mils, well, molarity, remember, is moles per liter. Okay? So, if they want to know mils, they want me to solve for this. This is what I'm solving for. Yes, it's liters. I'll just have to convert it, but that's what I'm solving for. In order to solve for this, I need to find this. I need to find the moles of HCl. And the way I'm going to find the moles of HCl is from the grams of calcium carbonate. Now, they gave us this equation in the problem. They gave us this value. They gave us this. They're asking for the mils. The mils are down here, the volume at least, the liters, which I can get to mils, are down here. So in order to do this, I have molarity. I need to find my moles. I'm going to do that up here. All right, calcium carbonate's mass, 40 plus 48 plus 12 is 100 grams. Calcium's 40, carbon's 12, oxygen 16 times 3 for 48. 100 grams of calcium carbonate is equivalent to 1 mole of calcium carbonate. Grams cancel out. Now, I want moles of HCl. Here's my mole ratio, 2 to 1. The one's assumed there. So for every 1 mole of the calcium carbonate, okay, I get out 2 moles of HCl. So I'm going to be able to solve for my moles of HCl here by taking 16.2 times 2, divided by 100, which should be 0.344 moles of HCl. If I did my math right. 2 times 16.2, sorry, 3.324. 2 times 16.2 is 32.4. Divided by 100 is 0.324. Yep. Okay. Now, I found my moles. All right. I found what I was looking for right there. To solve for my problem, I plug it in down here. So I'm going to have 0.383 equals 0.324 over x. So I'm going to essentially take this divided by this, guys. This divided by this to solve for x. X is equal to 0.324 over 0.383. Okay. So let's do that. 0.324 divided by 0.383. I'm getting 0.846. Now, here's the thing. That's liters. Okay? They wanted in mils, so make sure you answer the question right. They wanted in mils, so we got to move the decimal 3 to the right. It's 846 mils. And if I can make my 8s and my 6s better, I would. Okay. Math, man, math. Make sense? Any questions on this? I'm trying to keep it as organized as I can. I got my LCC shorts on today. All right, so what was the other one you had, Kelsey? Let's scroll back up. 4.92. Identify the oxing. Which one, A or B in 4.92? Or either one? Is it just the general question? I make it easy, Trenton, because I've been doing this a long time. You could get it down too. You just got to keep doing it over and over and over again. But I'll be honest, when I look at some of these homework problems, it takes me a couple seconds to, and I'm doing this forever. It takes me a couple seconds to organize my thoughts and everything too. Okay, so 4.92, identify if the reaction is an oxidizing agent or not. All right, let's see here. It doesn't matter which one we do. Why do they have to be so long? Why can't it just be short and simple? Well, let's do it. 4.92. Let's do 4.93. If you don't, since 9.2 is in the back of the book and you're just asking about redox reactions, let's just do 4.93 since 9.2 is in the back of the book, if you're okay with that. And then that way you'll have the answer to it that you can look up, and you'll also have 4.93's answer. So let's see. Tin solid plus 2H plus. All right. SN, I'm going to write these a little bit lower because I got to do some things with them. SN solid plus 2H2 plus aqueous yields, okay, SN2 plus H2 gas. SN2 plus aqueous plus H2 gas. Okay, they want to know what is the oxidizing agent and what is the reducing agent. Okay? Now, to do this, I need to assign oxidation numbers. Now, if you do it the way I'm going to tell you to do it, you don't even have to worry about these coefficients. The coefficient in front, you don't have to worry about it. So we want to know if something's losing electrons or gaining electrons. So we have to look at our oxidation rules on our slides. So it says that if I'm in my elemental state, how I appear in nature, my oxidation number is 0. So I'm going to use two different colors. I'll use red for tin, and I'll use black for H2. So they're both 0. Okay, if I'm in my elemental form, meaning if I'm a diatomic, I'm in my diatomic form. I'm a metal, I'm in my solid form. My oxidation value is 0. If I am an ion, my oxidation number is the charge of the ion. So 2 plus, okay, and this would be a 1 plus. Again, don't worry about the coefficients. Just write what your oxidation number is up on top. And now we're going to compare. We're going to compare tin on this side to tin on this side. And we're going to compare the hydrogen numbers to one another. Okay? This is how we do it. If there's a difference, I have a redox reaction. If there's no difference, I don't have a redox reaction. This is a 0, this is a +2, we must have a redox. If one of them's changed, something else has to be changed. Okay? If nothing else has changed, you did something wrong. So I went from 0 to +2. In order to go from no charge to a positive charge, I had to lose electrons. I went from +1 to 0. I went from being positive to being negative. I know I'm not negative, but I went negative. I went lower than what I was. So I must have gained E minuses. Okay, so then we go back to Leo the lion goes grr. If I lose electrons, I'm oxidized. Okay, so in our case, tin is oxidized. Oxide, I put oxidized. If I could spell today. You know what's going to be weird when we get to interact with other people again? Be like yelling at them, or I'll need to like hide behind a wall and talk in like a microphone or something. All right. This is where my brain goes. Sitting around here. How about hydrogen? Hydrogen is being reduced then. Okay? But that's not what they asked. They asked if I am the reducing agent or the oxidizing agent. If I'm the substance losing electrons and I'm oxidized, I am the reducing agent. So make sure you read what the question is asking. Is it asking, is it an oxidate? Is it being oxidized? Is it being reduced? Or is it asking about the agent? So if it's asking about the agent, you first figure out, am I oxidized or reduced? All right, and then if I'm being reduced, I'm known as the oxidizing agent. Well, here's why it's backwards, okay? And I used to think the same thing. So let's look at this, okay? Why is it that agent? All right? So here's the reasoning. All right, I'll do 4.92 then. I'll do that also. But here's why it's the agent, okay? Tin is being oxidized, which means tin is losing electrons. In order to be losing electrons, I've got to be giving them to somebody. So tin is giving the hydrogen the electrons, because hydrogen's gaining them. So tin is being oxidized, losing electrons, giving them to hydrogen, which is reducing it. So that's why it's called the reducing agent. Hydrogen is gaining electrons, so it's reduced. But where is it gaining it from? It's gaining it from tin, which is making tin lose them, which is oxidizing tin, which is why it's the oxidizing agent. All right, so let's look at one of the 4.92 ones then. Yes, whatever's losing electrons is oxidized, Rob. It's the reducing agent. So once you figure out what's being oxidized, it's the opposite agent. All right, 4.92. All right, let's do letter B. Since I already did a letter A, let's do letter B. Doesn't matter. They're done the same way. It's a long one. All right, we got 3 copper solid plus 8H plus aqueous. 3 copper solid plus 8H plus aqueous plus 2NO3 minus aqueous plus 2NO3 minus aqueous yields. I'm going to do it this way because this is a long one. It yields 3Cu2 plus 3Cu2 plus aqueous plus 2NO gas plus 4H2O liquid. Okay? So this is letter B, 4.92. All right, we need to assign oxidation numbers. So how many different things do I have? Well, I have a bunch of different things. So we'll just keep choosing colors as we go here, I guess. All right, let's look at copper first. Okay, copper's in its elemental state. It's a solid, so it's 0. Copper over here is a 2 plus because it's an ion. Okay. Let's look at hydrogen. Hydrogen is a +1. The reason? It has a plus charge. Over here, we're going to have to figure out what hydrogen is. Okay, we have to figure it out. And this is what the second part, the redox we started with, the redox video starts with, signing oxidation numbers. Okay, so let's look at oxygen. I'll use purple for oxygen. Oxygen, unless it's a peroxide. Okay, and in 4.93b, H2O2, that's peroxide. It's a -1 if it's a peroxide. But we're not a peroxide, we're water. So oxygen's a -2. Okay, -2, total of -2. Hydrogen's a +1 then. And if you do it this way, you don't have to worry about coefficients or anything. Just write it up here, multiply by the subscript, make sure they equal the charge. So oxygen's done. Okay, and hydrogen's done. Let's look at this oxygen. Oxygen's going to be a -2 for a total of -2. We'll come back for nitrogen. Oxygen up here is going to be a -2 times 3 for a total of -6. Okay? Now, we need to figure out nitrogen. I already used red. I used purple. What can I use? I got a green here. Let's use green. Okay? Let's look at nitrogen down here first. No charge. So what does nitrogen have to be? If nitrogen oxide or mononitrogen monoxide or nitrogen monoxide, however you want to call it, has no charge and oxygen's a -2, that means nitrogen has to be a what? Nitrogen has to be a +2. Exactly. So nitrogen here has to be a +2. times 1 plus 2 total. We're okay. Now let's go over here to this nitrogen. Oxygen's a minus 2 times 3 minus 6. Nitrate has a minus 1 charge. So when I add these numbers up on the bottom, it has to be a minus 1. So what does nitrogen have to be? Don't worry about coefficients. If you follow my method, it takes out the coefficients. 5, you got it. It has to be a 5. Okay, so a plus 5 and a plus 5 here to give me the minus 1. Now, everybody okay that's here with me, where we got the numbers from or how we figured them out, things like that, before I move on to the next part. It's all based off our oxidation rules. And guys, I mean, while you're taking the exam Tuesday, you can have them open. Like, I mean, there's no way of me stopping you from having them open. You'll have a periodic table open for yourself. You could have the solubility rules, for that matter, open. You're going to have 2 hours to take the exam. It'll start at noon. So it's 5 here because, okay, oxygen is always a minus 2 in our case here. Minus 2 times 3 is minus 6. Has to be plus 5 because when I add these together, it has to equal the charge on the ion. So minus 6 plus 5 gives me the minus 1. So down here it's a 2 because minus 2 for oxygen, there's no charge, so it has to be a plus 2. Plus 2 minus 2 gives me 0. Here it has to be plus 5 because minus 6 plus 5 gives me the minus 1. Yes, Trenton, exactly. These two numbers together have to equal the charge. The thing is, the book, and I'm telling you this right now, the book starts writing the numbers and then multiplying them and then multiplying by the coefficient and keeping everything up here. That way you would have to balance. This way, if you do it my way, you never have to balance the equation. You still get the same answer. If you're being asked, is it redox or not? Is what's being oxidized, what's being reduced, what's the reducing agent, that. If they're asking you to follow the electrons around, which I'm not going to do, then you have to worry about the coefficients. But to do what this question's asking, the coefficients are really irrelevant. Okay, are we good to move on then? All right then. So let's take a look. Now we look across the arrow for things that have changed. Copper is 0 here and a plus 2 here. So copper has changed. So we'll leave that go. Hydrogen is a plus 1. Hydrogen is a plus 1. It didn't change. So that's not part of anything. Now, if this changed, something else had to change. Let's look at oxygen. Minus 2, minus 2, minus 2. They're all minus 2s. So oxygen didn't change. Oxygen didn't change. Oxygen didn't change. How about nitrogen? Nitrogen did. Nitrogen's a plus 5 here and a plus 2 there. So let's focus on nitrogen and let's focus on copper. They're the things that underwent the change. Okay? So what happened? Copper went from 0 to plus 2. It went from 0 and became more positive. It had to lose electrons to do so. Therefore, it was oxidized. And therefore, it is the reducing agent. It went from 0 to positive. It had to lose negatives. Nitrogen went from a positive 5 to a positive 2. It got less. It became more negative. So it had to gain electrons. Therefore, it was reduced. And therefore, it is the oxidizing agent. That looks like gain. Let's do this. Gain E minus. Okay. Well, the reason it says that NO3 is the oxidizing agent because it contains the nitrogen. So the oxidizing agent isn't just the nitrogen, it's the chemical or the chemical formula that contains it. So nitrate is the oxidizing agent because it contains the nitrogen. Nitrogen's being reduced, but the agent contained that reduced substance. That's why, Kelsey. So if it asks what's being reduced, it's nitrogen. If it's asking for the agent, it's where is the nitrogen contained, and that's why they put NO3 minus. Mind doing A? No, that's why I get paid the big bucks. Not a pain in the butt. All right, let's go through A. We'll do it the same exact way. I put all my colors away. I don't know, my OCD got the best of me there. Let's take all our colors back out. Beautiful. Okay. All right, let's take a look. Put a black lid on the purple. Wow, my OCD is going to get real bad here. Got wrong lids. All right, 4.92A. 5H2C2O4. This is letter A. 5H2C2O4 aqueous plus 2MnO4 aqueous, okay, plus 2MnO4. Let me start it lower, just so when I write the numbers in here. 4.92A. All right. So 5H2C2O4. 5H2C2O4 aqueous plus 2MnO4 minus 2MnO4 minus aqueous plus 6H plus 6H plus aqueous yields 2Mn2 plus 2Mn2 plus aqueous. I can't stop making my cursive M's look like molarities. It's a disease. Plus 10 CO2 gases. 10 CO2 gases. CO2 gas. Plus 8 H2O liquid. Okay? All right. Pick one to start with. Let's start with hydrogen. Hydrogen, when bonded to nonmetals, is a +1 always. That is the rule. +1 for a total of +2 here. +1 for a total of +2. Carbon doesn't have a rule. We've got to skip carbon and we've got to move over to oxygen. Okay? Carbon doesn't have a rule. So we'll move over to our oxygens. There are no peroxides. I'm not going to give you peroxides on the exam. -2 times 4 is -8. Find an oxygen down here. -2, -4. And we'll do a -2 and a -2 there. Okay? I know. God forbid. What's her problem? Seriously. All right. Oh, I missed one oxygen. I forgot the oxygen over here on permanganate. -2 for a total of -8. Okay. And I missed the hydrogen. Jeepers. All right. Jeepers. What am I on Scooby-Doo here? All right. +1. Okay. Now, manganese, we should be able to figure out based on the oxygen. Carbon, we should be able to figure out based on what's going on here. Okay? So let's do manganese first. Let's use purple for manganese, I guess. All right. Oxygen's giving me a total of -8. The charge on permanganate's a -1. So manganese must be what? I just thought Kelsey was the puppet and you guys were all ventriloquists. That's what I thought. I'm a liar, I'm a sinner, I'm a sinner, I'm a saint. So what does manganese charge have to be? If this is -8, the total is -1. Manganese has to be a +7. Exactly. So manganese has to be a +7 here. Elena and Trenton, I'm not signaling you out, but you asked me about this on the last one. Do you understand why this one's a +7? We got it now? If not, I can go over it again. Again, not signaling you out. You guys just asked that question. I just want to make sure I cleared it up. All right, cool. Over here, manganese is a +2. It's a +2 because it's in its ion form, so whatever the charge is, that's what it is. All that's left now is carbon. Okay, so let's go down here and figure out this carbon's a little bit easier. What does carbon have to be in CO2? No charge on CO2. Oxygen's a -2 for a total of -4. What does carbon have to be? got it. +4. Okay. +4. For a total of +4. Cancel it out. All right, let's go over here now. This carbon. Now, here's where this one might be a little tricky. Carbon's total to cancel out has to be what? Carbon's total down here. What value has to be down here to cancel this out? Because there is no charge on this. So what does carbon have to be down here? I got a -8 based on oxygen. I got a +2 based on hydrogen. +6. Yep, +6. Now, since I have 2 of them, the oxidation number on carbon has to be you got it. +3. And you guys were nervous and said you weren't going to be able to do this. I believed in you. It's either that or I'm just that damn good. And I don't even need to be present live next to you to give you all of this power and wisdom. Or maybe it's a little bit of both. All right, let's see if we're redox. We need changes. Did things change? Hydrogen is a +1 on this side, a +1. It's still a +1. Hydrogen, nothing happened. Oxygen's a -2, a -2, a -2, a -2. Nothing happened with oxygen. All right, here we go. Carbon. Carbon, something did happen. Carbon is a +3. It's down here a +4. So something happened here. And this is another reason. Keep your oxidation numbers on top, your totals, because they'll screw you up. So something happened there. Just had some pizza bagels. So I have no. My motivation is I'm having lunch after this. So that's my motivation to get you to know it. Manganese, +7 to a +2. That did a change. Okay? So let's see what change we had. Carbon went from a +3 to a +4. It became more positive. That means carbon became more positive. Carbon, all right, in our case here, had to have what? If it became more positive, it had to lose electrons. Therefore, it was oxidized. And therefore, H2C2O4 is my reducing agent. Manganese went from a +7 to a +2. It became more negative. It had to have gained electrons. Therefore, it was reduced. Therefore, MnO4 minus is my oxidizing agent. Questions? Kelsey, has it cleared up for you? And everybody else for that matter? Rob, when they talk about agents, they want where the entire thing was, where the substance that's being reduced presides. So when they're talking about the agent, they want the entire chemical compound where the substance that's being reduced or oxidized is. Because the manganese itself is being reduced, but I need it to be in the permanganate form to be the agent. So yes, the carbon is being oxidized, but the carbon is part of this agent or reagent. Okay. All right, any other questions on the homework? Kelsey? Or anybody else? All right, let's talk about the exam then. All right, exam 2. Tuesday, April 7th. Is that right? Yes, April 7th. Because yesterday... on Blackboard, you'll have access to sign in and start taking it from 12 p.m. to 12:30 p.m. That will be your access time. Okay? You'll have, once you start the exam, you'll have 2 hours to complete the exam. It's a self-timer on Blackboard, and once your 2 hours are up, it submits the exam. We are not starting anything new until next Thursday, Trenton. I'm just going to go over stuff about the exam. So you're going to need to log into Blackboard, Learn. I better put Learn up there because people will be looking for Blackboard. You're going to log into Blackboard, Learn. In Blackboard Learn, it'll be under Assignments. It'll be under Assignments in Blackboard Learn. You'll see it there. Just like those of you who have me for lab, under the assignments you find the lab stuff, you're going to find the exam there. Don't mind this sexy leg that's hanging out there. It gets to be like 100 and some degrees in this office, I swear to God. And I have a fan going and everything. I don't want to leave the door open because the cats will be jumping up all over the place. Okay, any questions about how to take the exam or what? Okay. So our topics that you should be able to do. Number 1, do the homework. If you can go through all the homework problems in the book, you're going to be fine for this exam because it's going to be problems. It's going to be just like an exam I would hand out if we were live. The only difference is I can't give you credit for, partial credit, but you will have the answer in front of you because it will be multiple choice. So in chapter 3, you should be able to do mole conversions. So, for instance, that's moles to gram, moles to moles. All right, and back and forth. Moles to formula units using Avogadro's number. Stuff we've gone over. Okay? You should be able to do molarity problems. All right, finding the moles, how to make a solution, how to dilute. Okay, make solutions, just like the problems we did before, right before we left each other. I mean, I'm still here, I didn't leave you hanging. But make solutions, dilute solutions, things like that. And you should be out of chapter 3 able to do empirical formula work. You did a lab on empirical formula. You did a lab, the plant food lab, on the mole conversions. Okay, so chapter 3 is highlighted by this. There's enough questions here. Okay, those 3 topics. And all of it's in the homework. Okay. Chapter 4. The one we just finished. You should be able to do double displacement reactions. Okay? What I mean by that is you should be able to balance them. And find your products. Well, you'd have to find your products before balancing it, but you get it. You should know your solubility. You should be able to find complete and net ionic equations. Which is the metathesis reaction that you're working on this week for lab. I will tell you, because the numbers have to be exact to work out perfectly, Kelsey, so I don't want to make one up off the top of my head. But empirical formula, here, I'll type it too. Empirical formula is on page 137. Examples, 3.36 to 3.41, 3.43. So those right there, because the numbers have to work out just right for them. But those are your examples of the empirical formula problems. You're given like a percent carbon and a percent hydrogen, and you have to find the number of moles and then divide by the least number of moles. Yeah, I don't want to make one up and then it doesn't work out. But those will work right there. Okay. Number 2 out of chapter 4. Okay. Acid base. Okay. Strong versus weak. Okay. Naming acids. Titration. Remember, to be an acid, I have to be an aqueous solution. Okay. So if I'm not in an aqueous solution, my naming acid rules don't go into effect. Number 3, which we spent a lot of this video on, redox. Okay. Assigning oxidation numbers. Finding oxidative and reducing agents. We didn't go over weak bases, but for my acids we did. We didn't talk about weak bases. We did not talk about weak bases. I cut that out. If you're really interested about weak bases, you can go check out my General Chemistry 2 CHE 152 channel. We just did weak bases today. So that's why instead of throwing, if we were in the classroom where I could spend more time hands-on with you guys, I would have thrown that information at you too. Nope, you weren't missing anything. It's in the slides. Bronsted-Lowry weak bases is in the slides, but I skipped it to not give you so much stuff. Because it's not really covered in Chapter 4. I do it in Chapter 4 for completeness. Because they mention weak bases, but weak bases don't follow the classical rule. So that's why I do it for completeness there. Yeah, I don't know. I don't know what my subscribers are. I have old students who subscribe for it. Yeah, we have like 17 kids in the class and 29 subscribers. I'm almost there to get this monetized. I need 100, so I need, 71 more. And we can start making money off of all these lectures. Okay, so that's the information you need to know from Chapter 3 and Chapter 4 for this exam. We will have a review session on this stream on Sunday at, at 8 o'clock. 8 o'clock Eastern, live stream. I'll go over any of the homework or whatever you need. I have my math review at 7 p.m. When that's done, I'll come live on this channel. I'm going to be so famous. I'm going to be a YouTube star. Okay.